the sorting out the technical difficulties. I will pour myself a beer. Science in the Virtual Pub. Tonight's beer is a Southern Tier Citra. Delicious. Cheers.
And for those of you who are attending from the class Evolution of the Earth and Its Life, welcome. So I will, as the talk progresses, probably toward the end, I will put a link in the chat to a Google form with a question to ponder or reflect upon relevant to the talk. So you won't hear anything from me for a while, but maybe toward the end of Sylvia Reeves' talk, you'll get a text, not a text, a link in the chat.
Yep, I think it's a little big or something. Let me try one more thing.
I think while you're trying, I'll go ahead and play the coming attractions.
Sure, sounds good.
So welcome to Science in the Virtual Pub. And like I said, a little bit of technical difficulties, but we'll get started soon. And in the meantime, we'll go through the coming attractions and other info. That was the slide for our Learning Earth Educator newsletter. And there's where you can find all PRI events on the events calendar. We are normally started about now, but we will be started again very soon. And tonight's, so welcome to Science in the Virtual Pub for spring 2025. We meet on the second and fourth Thursdays of the month from late September through early May. And tonight's talk is the next slide.
All right, everything seems to be going wrong tonight. My apologies, everyone, but
we'll get there. I have confidence. So tonight's talk is Drought, Destroyer of Civilizations. Great title with Sylvia Reeves. 2 weeks from tonight, we'll have Jeff Abers talking about fishing for the faults that make the biggest earthquakes. A non-Science in the Virtual Pub event will be a teacher panel teaching high school climate change electives on March 19th. That's a separate registration. You can see the QR code there. Face-to-face workshop on March 22nd at Yuga Nature Center on data-driven stewardship, analyzing and protecting watersheds. Then March 27th, we'll have Chloe Arson from Cornell talking about renewable energy, but we don't have a title as yet. April 10th, we'll have Richard Kissel Dining in the Garden of Eden, Earth's First Herbivores and the Evolution of the Modern Terrestrial Ecosystem. Then our Earth Day event will be with Dr. Ben Luce talking about solar power now. And Ben is the chair of the board of directors for the American Solar Energy Society. And our final session will be with Dr. Sarah Worley talking about charismatic microflora. And there is where you can donate to Science in the Virtual Pub. And how are we doing, Sylvia?
Let's give this another try.
Okay, I will stop sharing.
And hopefully you will see my opening slide.
Yes, we still see the editing.
Oh my goodness.
But we can see your opening slide.
Yeah. All right, I think we're going to rock and roll with this for now.
All right.
My apologies, everybody. Just when you think you've got everything set up, something jumps in the way, but we're going to have a good time tonight. I am so pleased to be with you all because obviously as a meteorologist, I love to talk about the weather and in particular natural hazards like drought, because that is my focus, my job, my position right now with NOAA's National Integrated Drought Information System. We are working, or I am working specifically with the folks in the Northeast. So I'm really tight with the folks in New York and the New England states, but we've had some drought expanding recently on the East Coast. So now I'm working with about 7 more states just to our south in the Mid-Atlantic, and it's been an interesting 8 to 10 months here with regard to drought. Tonight, I hope to kind of shift the focus just a little bit, but certainly address a lot of your questions and engage in what I hope will be a lively chat about looking at drought and looking at other things other than drought. And I'm talking about archaeology and anthropology and history in general, which are all subjects that I am very much in love with, aside from the atmospheric sciences. So let's go ahead and jump right in. The disclaimer for tonight is obvious. I'm a meteorologist, not an archaeologist, anthropologist, or one of those wonderful professions. But again, I hope that's what our discussions are going to really focus on when we get through a couple of slides here. And it reminds me of my old days watching the Star Trek, the original series, and Bones McCoy complaining to Captain Jim Kirk that he is a doctor and not a engineer or an escalator, as I think the actual phrase was in one of the original series episodes. So please bear with me, and during the question and discussion period, feel free, if you are an archaeologist or an anthropologist, dive right in with me and have a great discussion.
Sylvia, we're still seeing the first slide, but it sounds like you're talking about the second slide.
Yes, I am. Oh, it's not advancing at all. I'm going to stop.
The joys of technology. There we go.
Okay.
Yep.
So I got through my little slide about Bones McCoy. Did you see that?
We're seeing it now, yes.
All right. And I wanted to give a little bit of my background so you can kind of see where I am coming from. And that would be to share with you my origins in the Midwest. I am a Midwesterner at heart, even though I've been in the Northeast for quite a while now. I was born in St. Louis and raised on the Illinois side of the river. So I always had this view of the wonderful Gateway Arch looking across the river. And if you can see, look kind of deeply in the picture there, you might notice that there's a bit of flooding going on in the Mississippi River. So I'm a kid that grew up on the river, watched it change through the seasons, through floods, through droughts, through icy flows during the early springtime. And as a child, it was just observations, along with the observations that occurred on land. Of course, this is Tornado Alley that I grew up in, and that undoubtedly sparked some of my own internal interest in science and in meteorology in particular, although I didn't know it at the time. I had no idea one could grow up to be a meteorologist and have a specialty like atmospheric chemistry or drought. But it did sort of evolve pretty easily. And there was another thing that I grew up with in that particular area. I grew up very close to the Cahokia Mounds, at the time a state park. It is now a UNESCO World Heritage Site, and it was home to the Mississippian indigenous tribes. So we're talking circa 600 to about 1400 CE, current era. And unbeknownst to me as a child, but still through sensing something special about this place, I was able to kind of talk with various folks, the park rangers, the folks who were indigenous and still remained in the area to learn a little bit more about what this incredible site was all about. What it kind of went through over the ages in terms of changes in the very soil that was beneath our feet at the time. And this particular map, you can kind of see a couple of different shades of blue where the Mississippi River is on the left-hand side of the screen. One is the course of the river as it appeared when this map was drawn, and the slightly larger blue-gray area is the course of the Mississippi as it has changed. So we know it's a meandering river. We know that some of the area just to the east of the river, which would be moving toward the right of the screen, had been inundated at various times when the river valley was larger than it was or when it had flooded. And that was the area where the Cahokia tribes made their stand again during that era between about 6 and 1400. So that'll play a little bit of a part in what we talk about later. Let me show you a current picture of what the Cahokia mounds, this is actually Monk's Mound, that was basically set up so that tourists can actually climb to the top of the mound. But here's a picture of what artists and archaeologists think it looked like during the peak of the Mississippian civilization. So again, terraced mounds, they were thought to have be related to religious and administrative functions during the heyday for this culture. And when I was growing up and hearing about the history of these mounds, it was very clear that that was something that the weather, the course of the Mississippi, these were things that I shared with the Mississippian culture, even if we didn't share the same time. And it fascinated me as I continued to grow and be exposed to other cultures like the Romans. And I'm always reminded that the Romans were very keen on the aqueduct systems that they built. And I do think it really lended to the sustainability of that culture. I once heard a history professor tell me that a culture that was able to control the water was able to to have great power in a region. And I do think that that has proved to be true, not just for the Romans, but in quite a few different cultures. Hopefully I'll get this slideshow to Don and he'll be able to share it with you later, but I want to be able to share some links to material that you can read. As I've come to study other cultures, I've come to learn about mega droughts, which probably is a phrase you've heard in the last year or so, mega droughts that have occurred in other parts of the globe. In particular, we're probably all familiar with Egypt, in particularly the Old Kingdom and how it either collapsed or some archaeologists and anthropologists say transitioned into the intermediate period because there was a major drought, a mega drought. And as we have, again, increased our knowledge about different cultures in the area during that same time frame, that mega drought that occurred that made that transition for Egypt also impacted other Mediterranean civilizations, actually all the way across the Indus Valley and into parts of China. So again, there's some history, ancient history there that really can tell some of the stories about drought. One in particular that I am fond of, because last year I got a chance to go to the Yucatan Peninsula, was to learn more about the Mayan civilization. And there must be 12, 13, 14, 15 different theories about why the Mayan civilization collapsed or disappeared or disintegrated. But several of them have to do with a major drought. It's pretty easy also to connect, and we'll talk about this as we go along, connect the Mayan civilization loss with cascade hazards. We'll talk about cascade hazards in a moment, but also coincidental detrimental events. It could be coincidental issues with invading tribes or war or a pandemic or epidemic of some type. So again, it's kind of interesting just to plow into the history and what we know through archaeology into these civilizations to see when they came to an end, what was it all about? What was going on? So again, I hope to get those links to you at some point so that you will be able to dive into the research of what some of the ancient effects were. But of course,
if you send me the slides, I'll add them to the Science in the Virtual Pub Events page along with the recording.
Perfect.
Session.
Perfect. I didn't want my lack of technological expertise to interfere with sharing some of this wonderful information. So I'm glad that's going to happen, Don. Thank you. But again, we don't have to go into ancient Egyptian history to see how weather and drought in particular can impact a civilization. This is a picture of Lake Powell with the classic bathtub ring from the decadal drought that occurred out in California and the Nevada and the Western states most recently. Key here to look at are those two towers there, which are actually part of a way to make energy. When the drought was at its peak, there were many reservoirs out in California and the West that looked a lot like this with a bathtub ring. And at some points, some of those reservoirs, which were actually hydropower generators, got to the point where they were very near dead pool, where they could not produce energy because there was simply not enough water. So again, we see not just from history, but from more recent events that drought is highly impactful in terms of not just agriculture, which is usually the first thing we think of, but also infrastructure, and even cases where human health is impacted. And just to kind of touch on human health a little bit, that's all connected through everything from infrastructure impacts to our drinking water supply systems, our farming, our agriculture. We're beginning to understand the links that have even appeared in the East more recently. The 2016 drought, which we have to think just a little bit further back for the Northeast. I had a friend who was an engineer with the city of Boston, who when the soils in the Boston area started to dry out, he noticed his workload increased greatly. And that was because they were having a lot of problems with pipes literally snapping as the ground was drying around them. And their replacement rate and the cost of keeping their drinking water infrastructure, sewer infrastructure up to par was really going up as that drought back in 2016, 2017 impacted them quite a bit. And then, of course, again, just back to the tip of the spear for drought being agriculture. Everything now that we're seeing in our markets that have to do with our beef supply is a little bit in flux because we've had just enough drought out west that it's getting a little expensive for some of the ranchers to haul in hay, haul in water, keep the animals alive and healthy. They're selling off the cattle instead. And that's actually producing an economic disturbance in our food chain. The poor gentleman on the left there is certainly mournful of the situation that he's in with the dry, cracked earth around him. And with some cultures, it actually creates food scarcity or impacts food sovereignty for specific cultures. So there are even links that we can look at now with regard to farming communities where we can equate the level or severity of drought with mental health issues. And that's everything from a farmer experiencing stress and anxiety to actual increases in suicide rates within farming communities. So we're literally beginning to get a lot better at keeping tabs on some of those downstream or cascade events that happen because drought has happened. Let me point out one more for you, one that is quite recent in time. The satellite image on the left is Lahaina and the fire that occurred there. It is, Lahaina, of course, is in Hawaii, and it is on the lee side of a range of volcanic mountains. And when you're on the lee side of mountains, basically when you get a wind coming across the top of the mountains and then descending, it's a drying wind. And that, of course, along with drought that was existing in the Lahaina area, and a hurricane that was nearby, creating higher than usual winds, then one little spark and Lahaina started. But again, it started with drought. The image on the right is actually from the LA fires. And you can actually see the heat in the satellite picture from the Eaton fire, but you can also see the smoke. And this is something that the folks downstream of Eaton and LA, Long Beach areas certainly understood. A consequence of fire was going to be that they were going to be inhaling more smoke, more chemicals from the actual combusted products in that smoke. And it's certainly a health hazard without a doubt. But again, a similar situation, we had some drought on the ground all the way up to about midway the California coast at the time before these fires started. And of course, with the Santa Ana winds that developed and just one spark, and unfortunately, LA had to experience what they experienced. But again, cascade effects from drought, leading to wildfire, leading to health issues from smoke. And now, as we're understanding, they are experiencing a next step in a cascade effect related to drought, which is landslides. So let me try to zoom in a little bit to kind of a model that talks about the cascade impacts related to drought. This is a series put together from the folks on Planetary Sciences Group. I love this particular diagram because it's so straightforward, but it also shows kind of a repetitive nature. Keep that in mind as we talk a little bit on the next couple of slides. A repetitive nature to drought and flood, or rain events and drier events. Often we have communities that are on the lee side of mountains, and there's, say, maybe a dry summer or two, or a summer with extreme heat events more frequent than they would normally get. You can see the ground drying out, and eventually the drought's going to break, and we're going to see some precipitation. The key is when that precipitation does finally get the ground nicely soaked, we start to see an increase in vegetation. And that vegetation then stays beautifully green until, in our little dry, wet cycle, we go back into another period of drought. And then we've got much more vegetation available because of that green up period. And then if we have, say, for instance, again, some dry Santa Ana winds, they call them Diablo winds, coming down that mountainside, and again, a spark, we're going to get those cascade effects, especially wildfire risk going up. And then that final portion of the diagram there does speak to debris flows or mudslides or landslides that occur when, again, you flip back to rain or increased moisture and precipitation. And with a denuded hillside, no roots structures to hold the soil, you're going to get it sliding right down the mountain as the precipitation flows down the mountain. So a classic example of a wet, dry cycle and cascade impacts all related to drought. And that's going to play a part. But what I would like to do is begin to engage everyone tonight in a look-see at drought conditions and some drought information that can be used to keep an eye on things, as we go along in the next couple of months in our own local area here in the Northeast. So if you will grab your cell phones and go ahead and shoot that QR code, it should take you right to the drought.gov website. And I'll give everybody just a moment to be able to do that. And then we'll talk through some of the things that can be found on drought.gov and actually tie that in to what our original question was about whether or not drought is a destroyer of civilizations. So I'm not sure, can you see, Don, if there's a show of hands that people have made it to the drought.gov website? A few?
Yes, people are getting there. I was responding to your question, but muted. I also put the link in the chat. So
got it. Great. Please click on that chat or just search for drought.gov there. And this was where I was hoping I would be able to walk everybody through, but I don't seem to be able to get it to come up into sharing. Don, can you from your computer?
Yeah. I thought you had it up there, but maybe that was me. I can do that.
Yeah, that might work out pretty well. I think I stopped sharing.
Yes.
And you're up. Yes, great. So this would be the banner head that you would see, NOAA, NIDIS, and drought.gov. And Don, if you click on where it says data and maps, you'll get a little drop down. And for folks who are on the phone, it looks a little bit different, but it is a menu option in the top right of your phone. So you can actually see some of the data. And if you'll click on historical information and go ahead and slide down a little bit, and you'll see a map of the United States come up. And that is a map which has data on it related to the US Drought Monitor. The monitor is updated once a week by NIDIS's partners at the University of Nebraska. The National Drought Mitigation Center is responsible for producing this map, gathering the data from across the country, as well as Alaska, Hawaii, and Puerto Rico, and the Virgin Islands, and putting together kind of a baseline of where we are with regard to drought. If you scroll down a little bit, down beneath that timeline, you'll see a legend. And it says yellow is D0, abnormally dry, all the way up to D4, exceptional drought. So that's the scale that we're going to be working with and taking an opportunity to actually take a look back in time to see if we can see some of the drought events and the patterns that may have impacted the United States, and in particular, the Mississippian culture. So if you'll slide back up just a little bit down to the map itself, you can see at the top bar, if you click on 9-month SPI. So the SPI is the Standardized Precipitation Index. It's a way we can take information on rainfall and hail and snow and crunch the numbers. And certainly that's available on the website if you want more detail on how we crunch those numbers and then put it into a gridded data format so we can map it out nicely. But the SPI is used to kind of calculate what has happened before with regard to drought. And this middle time frame is actually 1895 to present. So the time scale below the map allows you to use a slider. So if there's to the right of that, yes, you can actually slide your way through history, taking a look. And if you stop the slider on any one spot and click on that bottom blue button, it should give you the US map for the date that time hack is set for there. So we're going to kind of have a little bit of fun taking a look at drought history. What I'd like for you to do at this point is if you could hover over the state of Illinois with your cursor, and then hover over the state of Missouri with your cursor. We're going to put those two states together. We're going to create our own little map to focus on. This is a map of where the Mississippian culture existed. So scroll down just a little bit on that page, and you will see combined states. And if you click on that plus sign, and you see select a state, this gets a little hard on the phone for people who are working on their phones and maybe not on two screens with your computer, but you can certainly find Illinois and click on that, and Missouri and add that one. Okay, and combine. Okay, and we'll go back up to the map, and you'll see a highlighted version of those two states. So if you'll use the plus minus in the top left corner, you can zoom in a little out. We want it a little bit bigger so we can see a little bit more of the Mississippi watershed. Sorry, not zoom in, zoom out to capture a slightly bigger picture. That'll be good for the Midwest. And again, we're in that time frame of 1895 to present. If you click on paleoclimate, let's go to that. So we're going to a completely different time range that now fits just a little bit better with what we want to look at for looking at that Mississippian culture. If you scroll down to where it says time series options, it's a plus sign there, up, yep, you got it. And let's put in 1350 to 1450 CE is what we're searching for. So we want to basically zoom into that timeline, update graph, and let's see what we get. And we've got a little bit more focus on an era when the history tells us the Mississippian culture began to decline. And what do you see on that timeline? Above it, you see the hues of the U.S. Drought Monitor. And below it, you're actually seeing the correlation to flooding events or heavy precipitation events. And again, as we saw in that cascade diagram that we looked at, it clearly represents that flip-flop. Sometimes when we see it in the news, you'll hear it described as weather whiplash on a very shorter, much shorter time scale, but it certainly happens on a larger time scale as well. So if you could then slide your cursor over to that drought event that looks very dark there, that exceptional drought D4, and click on the bottom scale. Let's see if we can get it to map. And this is sometimes kind of hard to do. We might have to zoom in a little bit better. Yeah, okay. We're gonna watch that area just east of St. Louis where the Cahokia Mounds are located. Let's go down to time series options and zoom in even more time-wise. So let's go 1390 to 1400. Let's try that. A little easier to see on the graph. And hopefully...
Did it not take that?
It didn't take it that time.
So it was 1490, is that what you said?
1390, yeah. To about 1400. Let's narrow it down just a little bit and reset or update graph, and that should get it.
I hit reset graph rather than update.
Oh, there we go.
1490 to 14.
And again, to learn a little bit more about the detail of what goes into creating the paleo map, there is a link there below that says learn more about how we calculated everything. There you go. So at least on the timeline, we can see, what is that? It says 1892-ish?
1392, yeah.
1392-ish, sorry. Yes, what do we see there in the middle of the Cahokian Mounds area and the Mississippian culture? Certainly a drought. So that is the fun that I find in the lens that I look at history and archaeology and anthropology as a meteorologist. This is where it gets really fun for me, and hopefully interesting for you and for us to talk about. Again, there's more detail if you want to do a quick little wiki search on the Mississippian culture or the Cahokia Mounds. If you go into Wiki, I know they have right there on the main page kind of a timeline, a description of what archaeological digs have found and what that estimated time period is. And there's a period in there, I can't quite remember the exact date, but essentially it mentions a conflagration, which immediately takes me back to Lahaina and to LA. Something caused a major, major fire that did some damage to that civilization. Was it related to a drought? I don't know for sure. But certainly, when you get a pretty thick layer of ash, something big happened. Shortly after that conflagration, as the archaeologists described it, they began to see a decline in the population in that mounds culture, in the tribes that went from the St. Louis side all the way over to Collinsville, Illinois. So again, they are also looking at not just cascade events related to drought, but coincidental events. Was there, say, an issue with the fact that we knew they were growing corn, but did they rely so exclusively on corn that when corn was damaged, say, by an insect outbreak, right at the time they had a drought, or because they had a drought, that was also part of the decline of that particular civilization. Diseases like pellagra come to mind, where you're getting too much of one nutrient, but not a broad enough range of nutrients to be healthy. That could have impacted their society. A pandemic or epidemic could have hit in the area as well. But again, whether it's a cascade event or a coincidental event with other tribes having, warfare going on at the same time, fighting over scarce water resources, scarce food resources. It's all interesting in terms of what were the multiple factors that could occur. So I would say at this point, I would love to hear from everyone else in the room about what they're thinking about my crazy ideas at the moment, as I've shared them with you here. We could also do something, if you can, Don, go back up to the top of that map, and let's take it back to modern day. Let's go U.S. Drought Monitor 2000 to present. And let's slide over to the East Coast where we are. And let's see, I think we want to ditch Illinois and Missouri at this point. I think you can reset or eliminate show all, I believe. Or we could zoom in on New York or New Jersey, whatever state you might like to take a closer look at. New Jersey right now is experiencing some extreme drought. So we could zoom in there for a little bit of live view of what's going on. And I'll try to see if I can get into the chat. It looks like some questions are coming in.
Yeah.
Okay.
Why don't I combine states? New York and New Jersey in there together.
Question, for the LA fires, did the cascade start with the drought, or did it start the year before with a massive amount of rain? Good question. Again, both in the timeline and the sequence of events, we're seeing both. We're seeing dry periods and wet periods. Where it starts, it's been going on for a while, I guess is the best answer. But certainly with regard to the more recent LA fires, LA and that entire area was experiencing a decadal drought that had actually gone on a little longer than a decade. And then the drought broke, and you remember about 2 years ago, they started getting those atmospheric rivers, dumping lots of snow in the mountains, lots of rain. And it looked like some of the reservoirs, and they did refill quite nicely. Some that were further inland didn't quite refill. Some are still struggling again now. But basically, once those atmospheric rivers dumped the moisture, you had 2 years approximately, or 2 seasons of good growth of that underbrush that eventually dried out and caught fire and created the LA fire issue. So is that a chicken and the egg answer? Maybe.
We also had fires in New York and New Jersey this fall.
Let's talk about that. Right. This particular, what you're looking at now comes from this Tuesday's assessment of drought in our region. And it's it's a great improvement over September, October this past year. The exceptional drought, the D3 drought, actually extended pretty much all the way through northern New Jersey, a little bit into Delaware. There was also an extreme portion of drought in West Virginia, various time in the panhandle there of Maryland, and that Cumberland Gap area experienced, actually West Virginia's drought started probably in June, and then as it kind of progressed and moved east, we ended up being extremely dry all up the East Coast. Now, what was interesting about the drought is by the time it got to the East Coast, most of our agriculture was done for the year. Maybe there was a little bit of cranberry bog gathering, and they were a little bit worried about having enough water to flood the cranberry bogs and harvest that particular crop. But for the most part, by fall and September, October, November, agriculture wasn't a factor. But what was a factor was that the leaves had fallen off the trees, as they do in our beautiful New England falls. And because the ground had been so dry for 2 months, September and October, little if any rain in our region. So essentially we had a D2, D3 scattering of drought in the area, and all it took was a spark to get things going. I believe we had a fire in Brooklyn. We certainly had fires from Maine down through portions of New Jersey. A large fire on the New Jersey-New York border that actually took the lives of one firefighter. Connecticut, I believe, also had a line of duty firefighter loss, as well as a resident was lost. So these are obviously serious events, these drought, fire, wildfire cascade events. And it doesn't take a lot of land. I mean, you obviously have larger wildfires out west, but when you have a dense population, it's just as bad when you're trying to when the firefighters are trying to get a perimeter, and basically all they have is low ponds, hauling water, and difficulties trying to get the brush around it contained or cleared so they can get a good perimeter and cut off the fire itself from its fuel source. So we did have an interesting timing of our drought in the Northeast this past fall, in that it came right as the leaves were all on the ground and dried out. I think there's another question.
The question was about the effects of the budget cuts on drought monitoring.
So far, so good. We're still here. We have some major inflection points coming up. The continuing resolution, I believe, is March 14th, 15th, something like that. It expires. Hopefully, the government will not shut down drought.gov, but that is a possibility. And for those who are in the fields of agriculture or who are even trying to plan infrastructure projects or plan mitigation and resilience projects, that could be a heavy impact. We are watching in the Northeast whether or not our groundwater is going to be recharged to sufficient levels over the winter. We're getting good snow and some good precipitation in some areas in the Northeast, but not others. Massachusetts quite dry right now. Portions of Connecticut are still quite dry right now. And what we want to do with the wonderful snow that we do get is to have it do a slow melt so it soaks into the ground and soaks into our aquifers, and those aquifers are fully recharged by the time spring comes. Typical that we might have some spring flooding. We might see some of that weather whiplash where we go from a period of high rainfall or frequent rainfall, and then get a break, and then the rain stops, which is actually what happened last year in Vermont. We had a situation where we had our spring melt, we had a dry period, and then we had basically an opportunity for some severe storms to roll through and just totally go from near D2 drought conditions to intense flooding conditions. So again, I think what we can expect to see in the future is more of these weather whiplash type events on small scales, as well as like what you saw on the larger time scales that we observed in history.
And Rob's got a hand up.
Hi, Rob.
Hey, Sylvia. So I have it is kind of a segue what you just said to my question, which I know is difficult to answer, but so of course there's a lot of concern about what does climate change mean in upstate New York over the course of, the next 50 or 100 years, and this idea of possibly more extreme precipitation, but then also drought between extreme events. And for a while, maybe some years ago, I was asking colleagues, so do you think that the Northeast will eventually be a place where we have to worry about wildfires? And at that time, people said, no, I don't think so. It's still going to be pretty wet and so on. And I feel like the whole tone of that has changed through time.
Yes.
So I wondered if you had I know there are some changes in the long-term predictions, but what your thoughts are about how soon we might be in a position where New York State is going to see kind of the sort of large-scale wildfires that we're hearing about in other places.
Definitely not as large a scale as out west, just due to the way our geography is, our tree cover, our forests exist. I think what we're going to see is what we have seen. Everything old is new again. We're going to see what you saw on that 9-month SPI 1895 to present graph. You're going to see flips from dry periods to wet periods and back again. And the duration of those periods is what the research is focused on now. And is this driven by the ENSO cycle, El Nino and La Nina? Is it more influenced, particularly in the Northeast, by the Atlantic oscillations? And just because we're closer to the Atlantic Ocean than we are to what's going on the Pacific side of the country. So that is where our research is focused at this point in time. On drought.gov, there is a summary of a workshop that we did in 2023 called Drought Assessment in a Changing Climate. It's really good. It will tell you exactly, what NIDIS does really well is we bring a bunch of scientists together and say, what are our major gaps and needs, and where should our research go next? And there's a good summary in that report about the different areas that we want to look at. One of them is interesting. It's called precipitation effectiveness. And it has a lot to do with what I just talked about those aquifers recharging. In other words, are we going to get rain that comes down so hard and so fast that it runs right off into our river systems? Or are we going to get more periods of more events where the rain comes down slowly and soaks into the aquifer and soaks into our soils and keeps them primed for growing and healthy forests? The difference between a continuation of heavy, hard rains and gentle rains is going to be huge. And that's where, again, some of the research definitely lies with regard to drought in a changing climate. I would say that from this point forward, New Englanders, New Yorkers should not look at our region as being water rich. We are water adequate most of the time. But there will be these periods like this past fall, like 2016, 2017, like 2002. And then going back, again, if someone's out there playing with the timelines and wants to look at the drought of record for the Northeast, 1962 to 65. Incredible threat to New York City's, Philadelphia's, Boston's drinking water, to the point where they did get together and say, hey, we need to create a few more reservoirs. That was done, back in the late 60s, early 70s, took the edge off potential problems. But again, this past fall, if you were watching what was going on in New York City, their reservoir capabilities were getting pretty low, somewhat threatened. So I wouldn't say the Northeast is water rich anymore.
Thank you. That was a great answer. Full of interesting stuff.
Yes, indeed.
And depressing, but interesting.
Okay, let's talk about something less depressing. Let's look at the positive side of things. Everyone should know where their water comes from and be keen on doing your part in terms of water conservation. That's the old things like don't let your sprinkler system run and cover your driveway instead of your lawn. Water at the right time of day. Teach your kids to turn off the water when they're brushing their teeth. All of that matters during a drought and in a short term. But the other side of that is we have an opportunity to think long-term as well. We have an opportunity that we know, like my friend who's the engineer in Boston, that when we do have drought periods, the clay soils are going to make those pipes snap. So they're going to be a little bit more prepared. The next time they're watching the drought monitor show that it's getting very dry in the Boston area, they're going to be a little bit more prepared and ready with solutions to keep those pipes from snapping and losing more water in the process. So there's some upsides to being able to monitor drought just in real time. And then of course, looking at our short range forecasts, which are very good these days. And then, it's on us in the weather community to continue the research to improve our long range forecasts. Every farmer will tell you they're making decisions about when to plant and what to plant a season ahead of time, 4 months ahead of time. So that's one of the goals that we have, is to improve our precipitation forecasting out in that frame of time, 3 to 4 months, so that particular sector can get a jump on the preparedness needed for drought. Water managers, the same thing. Is it a good idea to lower the levels in the reservoir? Well, you know, if the 3-month outlook says it's going to be dry, we might want to hang back a little bit and preserve some of that reservoir water, particularly if we're expecting high heat summers. Extreme heat plays a huge factor in evaporation, both from surface water, but also evapotranspiration from our forests, our trees. Once we get some high heat in here, that'll accelerate evaporation so rapidly that sometimes that'll bring on what we call flash drought. So it just, within weeks, we go from abnormally dry yellow to something close to severe drought, some of the shades of orange and dark red. So hopefully that's a little more hopeful. Monitor, prepare, conserve. I think there was another question.
How much promise does AI offer with respect to improving the accuracy of long-range forecasting?
We think it's going to be very helpful. We do. I definitely do. It's going to be able to take this pattern recognition thing that we just played with to another level and say, well, we've seen this pattern before, and we have some indications about, say, what the next 1 to 7 days worth of precipitation is going to look like in the fall or in the spring, and that's going to really give us an opportunity to train those models, get that machine learning going, and see what the output is. Our models do a pretty good job, I would still say, on some levels that have to do with like major circulation, like where the jet stream is and where the flow is. But we haven't gotten it down to the point where I can tell Don that on your next birthday, you're going to see 1.5 inches of rain. Unless you're born in the winter, it might be snow, I guess. So yeah, we're going to have to work our way toward that kind of a forecast.
June 17th.
June, okay, it'll be rain.
Okay, 2 more questions have popped up in the chat. Has New York finished the work on the leak in the Delaware aqueduct?
They halted that work when the drought conditions went to a critical level in New York City, which was an excellent decision. I don't know that they've selected a date to restart that work. The Delaware aqueduct, I think they said that it was going to take a good 6 to 10 months to make that repair. So one thing they don't want to do is lock into that construction project at the wrong time. So again, they're going to be monitoring drought conditions, outlooks, longer range forecasts.
Okay, the next one is a longer one. Saving water is very important, of course, but so is taking individual and community steps to prevent water pollution. This includes so many aspects: not pouring oil chemicals down a storm sewer, not flushing pharmaceuticals down the toilet, planting native plants, shrubs, trees, and installing rain gardens, bioswales, to prevent rapid runoff, etc. I guess that's actually more of a comment than a question.
I agree.
Yep, me too. And the next one, another one just popped up. Can the drought maps be correlated with temperature maps?
Yes, there are. Remember, I talked about SPI, or Standardized Precipitation Index. There are many, I would say probably a dozen indices that we use in different situations to look at drought status and give us some idea of severity of drought. Several of them do involve temperature calculations. Not all of them do. So again, that's an area where we are doing a lot of research at NIDIS to see which indicators, which of these indices work better in different seasons, under different conditions, even across different sectors. Again, agriculture needs different information about drought than that Boston engineer would need. The lead time for ag is much bigger than the lead time say for water resources utility, or a drinking water utility, in terms of what they need to say get ready for that next period of low precip or drought.
And another one in the chat. Can measuring depth to water in a well be a stand-in for other drought metrics?
Oh, definitely. That U.S. drought monitor that we've been looking at all evening, typically we're looking at precipitation, of course. In summer, we're looking at temperature as well. We're looking at stream flows, and we're looking at groundwater. About a year ago, Western New York, I'm talking Wyoming County, closer to Buffalo. I forget some of the counties out that way, but they were having what we call a hydrological drought. They never got enough recharge in their aquifers. In other words, their wells, their levels in their wells were not refilling every winter like they normally do. And they had a couple of winters where it was kind of low snow or no snow in our area. I mean, yeah, we'll get the lake effect. It comes out in the form of a fire hose in a very narrow area. But there were some areas out in Western New York that just weren't getting the snow for a couple of seasons. And their gauges in their wells were very low or running dry. There were several dairy farm operations that stopped operating because they simply couldn't get enough water out of their ponds and wells for the cattle. So New York lost some dairy capability there for a while, about a year and a half ago. We had several small towns, Batavia, and I'm blanking on the other name, where it was right before, it's kind of a sad story, it was right before Thanksgiving. Many of the farms in the area their wells had gone dry, and they were trucking in water. New York State OEM and other entities were trucking in water, drinking water. And the town manager said, we're going to have Thanksgiving in the city hall. We're going to make sure everybody at least has a good Thanksgiving, even if we're having to truck in water and drink bottled water, etc. And the day came around, Thanksgiving Day came around, and the city town hall water ran dry. And so they couldn't even have Thanksgiving. Really sad story there, but it was basically, you couldn't tell it on the surface. It was all about the lack of groundwater availability and the fact that there were a lot of dry wells in that particular area. So there are times when even that U.S. drought monitor has trouble picking up on just one parameter, groundwater status, particularly when, say, the soils of about 1 centimeter to 6 centimeters might be very muddy or even moist, but it just wasn't making it down to people's wells.
Very interesting. I am in Western New York. I'm in just outside of Buffalo and Amherst.
Amherst, yes. Okay.
And it's been a very different winter this winter than the last few, where all the snow came in a few storms in the last several winters. I think this is the first time we had the ground covered by snow for a month in a long time in Amherst.
Yes, yes. I would, let me see, are you, you're still live here with your screen sharing. Do you want to scroll down a bit and let's take a look down below the map. Let's see, keep going all the way down. Let's see, maybe the map. I'm looking for something called the soil moisture map. It's not on this page. It might take a bit of searching to find, but that would be interesting to look at your area to see what that soil moisture is looking. It's probably looking way better than it did last year. And you are, again, getting at the point where some of the snow might be melting very gently now and starting to refill your aquifer. But click on drought.gov just up at the top. Yeah, there you go, soil moisture. Let's see. I want to zoom into Western New York and see how it's looking there. Okay, there we go, nice and green. We've even got some blues out that way.
Yeah,
So encouraging. What is a little worrisome is the gray area there. Some of this, isn't that Batavia?
Yeah,
In
Batavia is maybe right
right
about.
there. Yeah, I'm still a little worried about them in terms of recharge, but their different areas have gotten snow this year than the previous two, so that's kind of an interesting situation
I lived for a while,
going
so
on.
Michigan does not look so good.
The mitten does not look good. No, very dry out there. At least in terms of this particular product, NASA Sport. It's actually a satellite derived product that looks at soil moisture from quite a distance away, but it's usually pretty good. There's a couple of other ones. NASA Grace is another NASA satellite product that we use to keep an eye on soil moisture. But again, we have to combine this with what's going on below ground down in the aquifers. I have a question. Do we have an archaeologist out there or an anthropologist in the crowd who can maybe shed some light on some of my interesting thoughts as a meteorologist about the downfall of various civilizations related to drought?
Any takers on that? Stop sharing to see more of the crowd. Nobody's leaping at it anyway.
Mm-hmm. I think my theory is probably just too wild, right, Don?
Yeah, I don't know. No, I think makes sense to me. Last time my cousin was on, who is an anthropologist, but she's not here.
Oh, darn.
Um, and there are a couple more questions in the chat.
Okay.
In Florida, they want to pump polluted water deep into the ground, saying it is safe, which is not exactly a question, but something you can comment on.
I've heard of artificial recharge of aquifers. I do fear that it is not enough of a natural process, i.e. a filtration process. So if we've got our nice little snow on the surface and it very gently melts, it does filter through soil and rock and layers of rock as it gets down into our aquifers. That's a process I trust a little more than someone injecting water into, say, gray water into an aquifer. If there is some way that the process can be monitored and checked at all stages, I think that might be an interesting way to look at building out some more resilient infrastructure in the future.
Yeah, I wonder how deep that injection is. But
Yeah, with Florida, boy, that's pretty shallow, as I understand the geology down there. But
how
yeah, good question.
how deep are the holes? Um, the next question is groundwater consumption used in the drought monitor?
We do often, for instance, there in the Northeast and, well, many states, they have what we call drought task forces. And they're all of the state experts in various areas: forestry, drinking water representative, river associations, emergency management, public health. They all get together and look at all of the impacts that they're seeing or hearing about. And then the meteorologists come in and give them a briefing. And the River Forecast Center folks come in and tell them about the river flows, low flow, high flow. And all of those factors kind of come together to help them figure out or compare it to what they're seeing from, say, the USGS. Our partners at the USGS have gauges and gauging system and wells across the area that give us a better idea of what's going on with groundwater or other factors like surface flow and reservoir reserves. So all of those things, when you pull those groups of people together with all that expertise, they can begin to say, yes, we have something to be worried about here, because our reservoirs are already low, our aquifers are running low, surface water is trickling through. It may be, there's actually a lag from surface water becoming groundwater. So we could see a good rainstorm. And again, we've got great soil moisture. We've got our rivers and creeks flowing well. But again, it just takes a while, depending on the geology, to get down into the gauge levels or the aquifers and get a measurement from that. But all of those things, all of that information usually goes into those drought task force discussions. And each state is then able to say, okay, we got something to worry about here, or okay, we're coming out of drought, or we're status quo. And that's kind of where I spend a lot of my time, my work time, going from meeting to meeting, New York to Massachusetts to Maine to, again, since we're adding the mid-Atlantic states, I'm now getting more familiar with the geology in West Virginia. So it's quite a bit of geology and geography to cover, but most of the same principles apply.
Other questions? Can you either raise a hand or put it in the chat? And if you raise a hand with the reactions button on Zoom, you will move to my screen. So I will ask one. So you said a tiny bit about how a girl from outside of St. Louis became a drought scientist, but I'm wondering if you could expand on that a little bit.
Oh, wow. Yeah, I saw my first tornado at 10. I think it struck a nerve. Certainly with my parents hustling me to safety. And again, it was not anything I thought of as a profession when I was that young, but it was certainly enough to spark my interest in the science of it. And I knew it wasn't the only thing that was important. Again, there was this wondering about these people that used to live in the Cahokia Mounds area where I lived, and what were they like, and what was the history, and what did they do for a living. There was that interest as well. But as I also grew up during the era of Star Trek and the idea that people can come together and do some really great things exploration wise. So I thought I wanted to be a physicist, and I became enamored with Carl Sagan, and I ended up wanting to come to Cornell. And when I got to Cornell and spent my first year as a physics major, I quickly realized that that was not the path for me. It took about a year to figure out I didn't want to spend my life in a lab or doing just theory. I wanted something more hands-on, more real, more dirt under my feet and looking at the sky above my head. So I took a weather course my sophomore year at Cornell and switched from arts and science school to ag at the time is where the atmospheric sciences program was. And once it gelled, that this was it, this was the science, this was the people connection that I was learning about and becoming passionate about as a child, this was a field that I needed to be in.
I also started out as a physics major and ended up.
What is it about? It's the core science, so we all have to learn it, but
Yeah.
somehow, as you can probably tell from my personality, I would not have been a great lab person. So I'm more a people person.
Any other questions? Right. Well, I will put back in the chat some links for things coming up. I'm just going to copy what I had been putting in the thing while folks were in the
Well,
waiting
thank you
room.
guys for having me, and I apologize again for my technical problems, but I hope that I've left you at least with drought.gov for you to have a little fun to explore and learn and combine that with other fields that you are a part of or interested in, and shoot me an email if something comes to mind. Does drought affect this? How can we better predict that? I'd love to hear from everybody. Thank you.
Thank you. And 2 weeks from tonight, we'll have Jeff Abers talking about earthquakes and seismic stuff. Um, so thanks so much, Sylvia, and thanks everyone for coming. We had one of our biggest crowds ever tonight, so that was awesome. Have a good night, all.